Okay, so let's take a look at some of these homework questions. First it says match each pattern with its equations. So we've got three equations down here. They all seem to have a constant of 100. Some have a positive rate of change, and this one has a negative rate of change. So let's see what happens. In A, we've got 100, and we have 4, and then here it seems to go up by 4, and here, yes, we're going up by 4. So this must be pattern A, because we've got a rate of change here of 4. Pattern B has, again, a constant of 100, so we've got when x is 0, y is 100, and as x goes up, y also goes up, so there's a positive rate of change, and it's going up by 5 each time, so that must be pattern B. And Don has 100, he's withdrawing $5 each week, so the rate of change is going down by 5, so that must be pattern C. In question 3, it says Liz can ride at 15 kilometers an hour for a bike marathon. Describe the relation between time and distance using a table. So if we use a table, we could say that when time is 0, the distance traveled is 0. When time is 1, she's traveled 15 kilometers. When time is 2, she's traveled 30 kilometers. When time is 3 hours, she's traveled 45 kilometers. Now it says represent the relation between time and distance algebraically. Well, you'll notice up here that when time was 0, distance was 0. So there was no constant always being added. So the distance for part B here is that distance is simply 15 times the time, right? 15 times 1 is 15. 15 times 2 is 30. 15 times 3 is 45. So part C, this was part B, part C says, how far can Liz ride in 8 hours? Well, the distance is 15 times 8. So 15 times 8 is 10 times 8 is 80, 5 times 8 is 40, so 15 times 8 is 80 plus 40, or 120 kilometers. And finally, how long Liz will take to ride 100 kilometers? Well, for part D, the distance is 100, and we're going to solve for t. Sorry about the mess here. To get t by itself, we need to divide by 15. So t is whatever 100 divided by 15 is. So that comes out to 6 and 0.66, or 6 and 2/3 hours, or what's that? 6 hours and 40 minutes. So in question 5, Eli created this toothpick pattern that we see in front of us here, figure 1, figure 2, and figure 3. It says make a table of values for the number of toothpicks in each figure. Okay, we can do that. We'll say n is the number of the figure and t is the number of toothpicks. So in figure 1, we have 4 toothpicks. In figure 2, we have 7 toothpicks. And in figure 3, we have 10 toothpicks. So it says write an equation for the number of toothpicks in figure n. Well, if you notice that it goes up by 3 here, so that tells me that the number of toothpicks is 3 times n plus 1, right? Because I've got 3 toothpicks here plus the 1, those 3 plus another 3, those 3 and those 3 plus another 3, and that 1. So the number of toothpicks is 3n plus 1. And then we can use that to figure out the number of toothpicks in figure 8. So t is 3 times 8 plus 1, or 24 plus 1, or 25. And how would you verify it? Well, I guess you could make figure 8. Which figure will require 46 toothpicks? Let t be 46, and that's 3n plus 1, and then solve for n. And I'll let you do that on your own.